The first data types we're going to discuss are the numeric data types. We're going to start with the data type for whole numbers, which are integers, and the key word for that is int, int. That's the word we use in C++. An integer can hold a number that contains up to 4 bytes. Now, for a lot of people that doesn't mean very much, so we would say instead that the storage capacity of an int is from -2 billion to +2 billion, and that's approximate. It's actually just a little bit over that. If you have a number that won't fit into that range, there's yet another data type you can use called the unsigned int. It will hold up to 8 bytes. Now notice it says unsigned. That means that it can only be positive numbers. So the range of an unsigned int is from 0 to approximately 4 billion. Again, that's approximate. It's a little bit more than that. Let's look at an example of simple C++ program that demonstrates the difference between int and unsigned int. This C++ program assigns the variable num the value 2 billion, and then we simply write it out to the standard output to see the value. So let's build and run that program right now. There we see that the output is indeed 2 billion. Now let's change the value of num from 2 billion to 3 billion. Simply change the 2 to a 3. Now let's build and run again. And this time we see that the number is something different. It's not 3 billion. It's really just a nonsense kind of junk number that C++ pulled out. That's telling us that the value stored in the variable is too much for the data type. To fix that, we come back to the program, change the data type of num from int to unsigned int, and then build and run the program again. And this time we see that indeed num can hold the value 3 billion. So unsigned int can be used when you have very large numbers as long as you're going to use them for positive values only. After integers, we have data types for floating point numbers. The most common of those is the data type double. It can hold up to 8 bytes of data, or 1.7 times 10 to the 308th power, or 1.7 times 10 to the -308th power. Another data type for floating point numbers is the float data type. It only allows 4 bytes of storage, and it's not used all that much in most programs. The range of the floating point data type is 3.4 times 10 to the 38th power, or 3.4 times 10 to the -38th power. Before we leave numeric data types, let me show you one more thing you can do to examine how much a data type can hold. There's a nice little function called sizeof. All we have to do is write the function name followed by a data type. Let's do int first. And the function will tell us what size can be stored in an int. So let's build and run. And we see that we can store 4 bytes. Let's do it again with the unsigned int. Build and run. Now that's a little bit confusing because it says 4 bytes, and that is what it says, but as you've seen before, it can store a larger number. Let's do it one more time. This time let's put double in as the argument. Build and run. And this time we see that it can store up to 8 bytes. So the sizeof function is a convenient way to check the size that your data type will hold. I forgot to mention earlier that the size of a data type is compiler dependent. So every time you run a different compiler, you might need to check to see what the size of your data types actually is. In the next video, we're going to talk about strings and the string data type.